Hey scholars, this is Mrs. Gregerson, and I am so excited about this lesson because it's to me, it's one of the funnest ones in chapter 11, and I'm actually combining the first half of section 4 with all of section 3 because the whole process is finding the measure of angles and their relationship with circles. And it's really unique because as long as you know where the vertex is, you can figure out the relationship. So we have a few definitions we have to get down first. The first is called an inscribed angle. Now I want you to think about this. I'm going to draw it off to the side. When I had an inscribed polygon, where is the vertex of each corner of that polygon? It's on the circle. Well, that's actually each one of those because an inscribed angle's vertex is on the circle and its two sides are made up of chords. So an inscribed angle is just that, an angle whose vertex is on a circle and whose sides contain chords. So down here in this diagram, we know angle DEF is an inscribed angle. Now, here's the cool thing though. Now, we're going to use terminology to solve for words we called an intercepted arc. And like in football, you hit something, you walk in front of them. When I say intercept, you went in front of that wide receiver and grabbed the ball. You intercepted it. You're in the same line. So when we have an intercepted arc, it is actually the arc found when I take my angle and I cover up everything as what is between the two sides of these papers here. In fact, I call those kind of like arc finders. They help you give you that visual cue of what you need. Every angle has an intercepted arc or intercepted arcs, as you'll find out today. So here for this inscribed angle, this is your intercepted arc. Now, using what we know about these angles, we should be able to figure out a little bit about degree measurements. Now I want you to go back to what we know the other day. We know if I have a central angle and its vertex is on the center of the circle, the angle and the degree measure of the arc are the same. So I'm pretty excited about that. But notice if I draw in a central angle here in this diagram, and you don't have to do that, notice, is this angle smaller than that one? I hope you realize, yeah, because if I had literally kept my hand, let's use the arc finder here to help me out. If I literally kept this at that size and I go back, look at the measurement there. It's half its size. So the inscribed angles are going to be smaller than the central angle. The central angle is the same as the arc, but the measure of an inscribed angle is half the measure of the intercepted arc. So it's half the measure of the intercepted arc. So here, we're going to say the following. If this is angle 1, the intercepted arcs, I'm going to do all the intercepted arcs in this case in purple. Notice these are all different ones. You can see that's very purple very much on the thing. But all of those are the intercepted arcs. Your inscribed angles, notice where the vertex is located on the circle. So think about those, and I'm going to redraw all this a little bit. I'm going to call this x degrees, x degrees, x degrees. I'm going to say then the measure of the angle is 1/2 of x degrees. Now, if I know the angle, I just double it to get the arc. So we have that relationship with it. So you have to know what the arc goes with what angle. So here's an example of this. It says find the measure of angle PRU. We're going to play connect the points, right? Well, with PRU, it's an inscribed angle. Its vertex is on the circle. And what is the measure of the intercepted arc? Well, the intercepted arc is everything between the two sides of this blue piece of paper, okay? And so that's going to be 118 degrees. So the measure of angle PRU is 1/2 of 118 degrees. So half of 118 degrees, it's going to be 59 degrees. Now, let's keep using that to our advantage. Now, this time it says find the measure of the lovely arc. Well, this time they want to know the measure of arc SP, so we have this minor arc that we're working with. Well, we need an inscribed angle or a central angle to help us find it. Well, which one intercepts it? Well, this angle right here. And oh, look, that's an inscribed angle. Its vertex is on the circle. So that then means I should be able to find the measure of the arc if I know the angle. So to just go the opposite way, instead of dividing in half, I multiply by what? 2. So I go 2 times 27 degrees, and that's 54 degrees. All right, we're going to keep using these, and we're going to apply some more, but we're going to go now to the next page.